this webinar how to get an extra 1.5 fuel saving on any given vessel using Seakeeping. This is a joint webinar together with ABB. My name is Mark Streuper. I'm from DTN, also known as the former name Meteor Group. Some specialists will join. One specialist from ABB, Jan-Jaap Stoker, and my colleague Matthew Corey will join from the product department. Some housekeeping. This webinar will be recorded and will be available after this webinar. So no point taking screenshots or record it yourself, you will get it. At the end, we will try to answer questions. Questions can be asked in the Q&A. I will write them down so you can answer them at the end. If there are any technical difficulties, also send them to the Q&A and we try to figure it out. What we will be sharing with you today is an introduction, because for some people DTN is still new. We will talk about Seakeeping together with ABB, route optimization in the combination with Seakeeping, voyage options and the potential savings, and at the end the Q&A. So a lot of people think, well, where is Meteor Group? Meteor Group now has merged with his big brother DTN, so the Meteor Group brand will disappear completely. So all our brothers and sisters will move to the DTN logo and the DTN brand. And we're not only working in shipping, we're also working in agriculture, energy, and the general weather business, but also financial analytics. I call it, if you know Bloomberg, it's pretty similar to what we are doing. And the weather business is connected to, I think, 70–80% of all businesses is weather related, or at least influenced by weather data. So I think we play a big role in determining and managing all kinds of different businesses. This webinar is together with ABB. We're working together for more than 10 years, I guess. Having also motions into account into the SPOS system. And ABB is a global technology leader when it comes to all kinds of solutions. I added a few slides from the last webinar, 2019. And it was more the technical part about Seakeeping. At the end of this webinar, we will share the recording itself, but we also will send a link to the webinar we did in 2019, which is more a technical one. It's more about what's Seakeeping, what is octopus Seakeeping, what's 2D motion prediction, 3D motion prediction, and how does it come all together in the SPOS system, so you can use best of both worlds. Use the DTN SPOS solution together with the ABB octopus solution, from weather forecasting to onboard sensors, routing algorithms from our side, then predict motions from the ABB side, and use them all in one solution. So you can take into account sea and swell height, sea and swell period, vessel speed and the course of the vessel, course, the difference between different kinds of hull shapes make a big difference. Stability, the GM, and the forces and motions on the different kinds of cargoes which are in or on the vessel itself. I'm switching over to my colleague, Matt. Matt, the floor is yours. You're in control.
Good. Thank you, Mark. And hello, everybody. Let me get to the next slide here. My name is Matt Corey. I am a Senior Product Manager here for shipping at DTN. And I'm going to talk briefly about what is SPOS and the ingredients and process that goes into creating a weather-optimized route within our SPOS application. So first off, what is SPOS? It's a Ship Performance Optimization System. And what does that mean? It's onboard vessel decision support tool empowering our clients to increase vessel safety, save fuel and time via optimal weather routing, and unburden captains. Key features of SPOS: weather forecast visualization. As DTN, we are the world's largest private weather company. We have access to a large amount of global weather and oceanic data. However, onboard vessels, we can't always be as connected as we want to be. So SPOS is a bandwidth-sensitive application that does great things with the compressed data we send to each vessel each day all over the world. And at the core of that weather data is what we call the NMB, the Nautical Meteor Base, which is a verified weather data. I call it fit-for-purpose data for the bodies of water wherever you are. We use observations such as satellites, buoys, vessels, and more, and determines the most accurate forecast model for each area. SPOS also enables new reporting. Those reports are ingested into the DTN performance system and quality checked and analyzed by the DTN analysis team. And SPOS is part of shared reality between onboard and shore-based products. At DTN, we have the Fleet Guard, Fleet Management Web application. We also have Route Guard, which is our routing consulting team at DTN, which consists of many master mariners. And those route advices from Route Guard can go back into SPOS, which completes that circle of shared reality. One of the most powerful features of SPOS is the weather-optimized route planning, which is why we're here today. So what are the ingredients for weather-optimized route planning? Well, weather data is quite important, updated regularly, and has to be fit for purpose. Ship profiles, which are sophisticated models representing vessel characteristics, but also take into account impacts of environmental conditions on a specific vessel's performance, things such as wind resistance, wave resistance, swells, etc. But the angle of those elements versus the heading of the vessel is quite important in determining the resistance and hence the vessel's performance. That leads us to the weather-optimized route network. The network provides safe passage through restricted areas to stay in designated TSS lanes, but also frees the vessels for maximizing the open waters available. Unlike other services that simply follow traditional shipping routes or AS pollings, these open areas are where we can safely make recommended course and speed changes to minimize the environmental resistances on the vessels and maximize the vessel's performance. And finally, the routing algorithm itself is the glue that brings all the above together. It has to be fast and accurate, and within SPOS, enables a master to repeatedly open and close passages as an interactive tool for maximum flexibility. So now we have the ingredients. So how do we do it? What's the process? Again, first part, weather ingest. You have to ask yourself, do we have the right data? And always use the latest weather data. As a meteorologist, I'll say that again. Always use the latest weather data. Now, safety settings. What safety thresholds are critical to your vessel on this voyage? So standard parameters we have, such as wind and waves, swells, tropical cyclone distances, icing, etc. But we also have derived parameters, such as in Seakeeping. We have roll, pitch, slamming, synchronic roll, parametric roll, surfing, high wave groups. And within the algorithm, we offer the ability to warn or avoid. If you warn, the algorithm will give you a route that will, at the end of the route, warn you all the times that your threshold has been breached, or avoid, as it sounds, will actually avoid those critical thresholds. Next are the restrictions. We have ice restrictions, vertex. You can do user-defined restriction areas and more. Plus, we also have the ability to put in waypoints. So not just where you don't want to go, but also where you do want to go as part of the algorithm. Vessel settings, is it a laden or ballast voyage? The vessel model you can select from our inventory, adjust the fuel speed curve, or use our trim advisor module. And within SPOS, we have different routing types, such as fixed speed, which is used for charter party or slow steaming, variable speed, speed up or slow down or miss weather features, fixed ETA, set when you need to be there and get the best, most economical route to get you there on time. And you can optimize by fastest speed, you can optimize by fuel, the lowest cost of fuel, optimize by cost, which is also the fuel, but takes into the daily hire and other costs. And finally, I got a screenshot here of SPOS from a couple of days ago, and the light gray is the SPOS fixed speed with standard thresholds wave tolerance, and the dark gray route you see here was using Seakeeping, and it was set to avoid moderate motions through the voyage. In this case, the weather over this route was already marginal, but with the impact of the vessel via the motion predictions, the recommended route was altered to stay within the voyage vessel and cargo limits. In essence, the Seakeeping module helped make a better decision sooner, which saves money. So to summarize, this section anyway, weather optimized routing is a great way to save money. We often save as much as 3 to 5% per voyage. With increased fuel prices, outside of COVID that is, and the coming GHG regulations for 2030 and beyond, weather optimized routing is quickly becoming a key method in managing costs. SPOS is a powerful and flexible onboard decision support tool empowering our clients with that weather optimized routing. And within SPOS, we have options such as the Seakeeping module via ABB that takes the decision support to another level of intelligence. It focuses more on managing the impact of the sea state on your vessel's motion versus the sea state itself. I look forward to answering more questions at the end. Next up, I'm going to hand over to Jaap-Jan.
Good morning to you all. Good afternoon. My name is Jaap-Jan Stoker. I work as solution manager at ABB within the digital team. And my responsibility is to work on new solutions within the Octopus product. For this webinar, I'd like to present and maybe also discuss later on in the Q&A about the savings and the savings potential of such kind of workflow using responses in your route planning. Because most of the time when we talk with clients, of course, money comes on the table first. What is in it for me? And initially, it's not directly possible to say because we don't know the benchmark of the client themselves. But here I'd like to give you a straightforward example how you can also make this kind of assessment yourself. So I will run through 3 different options to go through a route with a normal vessel at a normal speed. What is the effect if you deviate around bad weather? And what is the effect of the timing of deviation? So if we take the best possible voyage, you go from pilot station A to pilot station B through deep water. It's a simplified way for a route. And you have a vessel, if you look in the left bottom graph, with a speed fuel curve. If you go in stable weather from A to B and you encounter bad weather, and let's say a sea state of HS5, and your average fuel consumption is about 25 tons per day. On a distance, a voyage of 10 days, you sail about almost 2,900 nautical miles with an average speed of 12 knots. And your total fuel consumption approach 250 tons. In this case, you go as stable as possible in the shortest route from point A to point B through the difficult conditions. If we take the next step, was going a bit too fast. You sail in a stable condition with your 12 knots, the same as the previous voyage, until you hit the bad weather, and then you decide to reroute. But to maintain your ETA, you have to deviate and increase your speed. In this case, would be to almost 14.5 knots. The effect of this is that you make more nautical miles at a higher speed at the second part of your voyage, which has an influence on your fuel consumption. This is just when you sail up to this weather and you make the assumption you cannot go through it. And if you then check what could have been the alternative, is that if you have your process in place in making the assumptions and check for your possible rerouting, maybe one of the options would have been that you reroute at an earlier stage. If you make the assessment, for this you need to have what Matt already said. Of course, you need to always take into account the latest weather forecast, but also take into account what are the boundaries of our vessel. Can we go through the bad weather, which has been predicted maybe 2 days ahead? And the earlier you make that choice and the better you adapt, the bigger the potential saving is. Because if you reroute at an earlier possibility, your total distance will be less, and especially the effect on your average speed will be lower. And in this example, of course, you start your voyage as the weather would be fine with 12 knots, but when you deviate, you have to speed up to maintain your ETA, and in this case, you have to speed up to 12.8 knots, which will lead in a total fuel consumption of about 288 tons. If we combine this, you get a basic overview of what are the options in this kind of for this kind of route, and what are the difference in cost. And what was the header of this webinar is to save 1.5% for any vessel. Of course, this is flexible, but if you compare the different options and you do it based on, let's say, vague limits, that one captain could say, I will always deviate around 5 meter wave height independent of what, and another would go to 7 meters, or another one would take into account the actual behavior of the vessel. And taking into account the actual behavior of the vessel at the particular moment would lead into a late deviation, because you sail until it becomes too dangerous, or it becomes too not comfortable enough, and then you deviate, and that's a late deviation. So taking a risk can cost a lot of additional fuel. So in this case, if we look, the most important part in this kind of assumptions is to limit the gray area. If you go from point A to point B, you have several options to reach, of course, point B, and you want to reach it in a safe and efficient manner. But within that, you always have a gray area, and the target is to limit the gray area. And in our view, and also our experience, operation depending on vessel behavior is a huge step forward, instead of only doing it on a limit of wave height. And the important is that the decision and the support is available as fast as possible to the master, that he can make his decision based on the best data available. And the earlier you can make your decision, the better it is for the overall view. And maybe to summarize it here, is what we aim to do with the Seakeeping Assistant is to limit the gray area where different plannings can be made depending on the conditions. And different plannings is depending on experience, on the actual condition, what somebody feels. And here it can deviate between rerouting or even waiting for the bad weather, or just go through the bad weather. And in this sense, this is what we try to limit with our solution. Then I will forward to Mark again, and I'm looking forward to receive any question.
Thanks, Jaap-Jan. Thanks, Matt. Yeah, I think the conclusion of this webinar is if you combine the solution from ABB, Seakeeping, Octopus Server together with SPOS, putting the two together, you can do something more than just optimize the route and optimize on safety. And basically what we are saying in this webinar is you can use Seakeeping on any given vessel, because out there everybody knows, okay, Seakeeping is being used on container vessels. Yes, we have a lot of container vessels equipped with Seakeeping and Octopus Server, but in this webinar we are showing, okay, it's not just containers. Basically on any given vessel you can reduce your cost with 1.5%, and that's a lot of money. Q&A. Okay. If you have any questions or more questions, just put them in the Q&A. I've received a few questions on ship profiles. Ship profiles in SPOS, ship profiles in Seakeeping, ship profiles in Octopus Server. I can refer to the technical webinar. The link will be shared, but in short, there's ship profiles in the SPOS system. There are ship profiles in the Seakeeping solution. So it's like a library where you can select your vessels. If you say, well, I want to have more detail, be more specific, more accurate, then you have Octopus Server, where we calculate the motions on a 3D level. Then we will ask for more hull specifics, and ABB will engineer a so-called CHDB file to make the best 3D calculations possible. Another question that came in was, okay, looks like a nice theory, but has this been tested in real life? And the question is yes. So we're not making this up, saying, okay, we want to do a webinar, let's make up a nice story. No, we got this idea from a real live example, and we want to share this with the entire world. So it's not just on paper, we know it works in real life too. Okay, these are the questions I received. I got another one. Just reading out the is this a full software solution? Yes, it can be put together as a full software solution. Also, SPOS is working independently. Octopus Server can work independently, but you can also combine them in one solution. Another question, is the routing adaptive to the actual loading condition? Okay, maybe I need some help from my colleagues and specialists.
Yeah, maybe I can take that. Loading condition, what I read, is the routing adaptive to the actual loading condition? Yes, this is actually one of the key features, is that your vessel is depending, or the behavior of your vessel is depending if about the draft, but also of course GM, and this is taken into account on board the vessel at the moment of planning your route. The hydrodynamics to calculate the ship motions are taking into account the latest loading condition, and this can be automated, but it can be also a manual input. And then, of course, in case of a manual input, the crew needs to put it at the moment of routing. They have to put in their stability figures.
Okay, thank you, Jan. Got another question. The Seakeeping module, is that one available in SPOS, but also in FleetGuard? At the moment, it's available in SPOS only, so not in FleetGuard. But perhaps a nice idea for the product department to have Seakeeping also available in the office solution. Another question, how do you take into account specific hydrodynamics of the vessel in SPOS? And is there a trim optimization option? Matt?
Yes, the answer is yes. Hydrodynamics are set, and within SPOS we have the trim advisor module, which is part of the vessel selection and then the vessel performance that you can select. So the answer is yes.
Okay. Yeah, it's 10:30. I think it's a nice time to wrap up, so everybody can also get back to the other activities and work which needs everybody's attention. We will follow up with an email to this recording, but also the recording of 2019 on the more technical details. We will share our contact details, so if you want to discuss this more in depth, feel free to contact us. Yeah, and thank you for attending this webinar.
Yes, thank you.
Thank you.